In this video, we'll look at rates of change with max and min. So this question comes out of your textbook, page 201, 3e. The function is f at x equals 2x cubed minus 3x squared minus 12x plus 1. And it wants to know where the maxes and mins are between -2 and 0. Okay, well, first we'll take the derivative. F prime at x is, we're just using power rule here, or the derivative of a polynomial. Exponent comes down and multiply. 2 times 3 is 6. Subtract 1 from the exponent. Exponent comes down. 3 times 2 is also 6. Subtract 1 from the exponent. And negative 12x derivative is negative 12. To find the max and min, we're looking for critical points, and that's where f prime at x equals 0. So set f prime at x equals 0. And now we'll solve. How do you solve that? Well, you could do quadratic formula, but I'd rather you factor it because it's faster. That is, I can common factor out a 6 from all three things. Please watch the videos on factoring if you don't know how to do this. And I get 6 times x squared minus x minus 2. And now we can use Bergman technique. What multiplies to -2 and adds to -1 is MAN. The numbers are -2 and 1. Again, there's videos on that. And so you get 0 equals 6 times x minus 2, x plus 1. And so we'll set both pieces equal to 0. X minus 2 equals 0, so x equals 2. And x plus 1 equals 0, so x equals -1. And so this one we reject because it's out of range. So we reject it. That is, it has to be between -2 and 0, which 2 is obviously not. But this one's in the range, so we're going to check that one. Let's go over here. We're going to check 3 places. We check the endpoints and x equals -1. And we want to see what all the values are at those spots. So I want to know what's f at -2, that's one of the endpoints. And I want to know what's f at -1. And I want to know what's f at 0, my 2 endpoints, and this max or min that I found. Okay, what do we do to do that? Just sub in. What's f at -2? I have to sub in. So that's 2 times -2 cubed minus 3 times -2 squared minus, I better go down here, 12 times -2 plus 1, which equals, you don't have to show your work in calculus, but I would, just in case you make a mistake. 2 times, so this will be 2 times -8, which is -16. I can give you part marks if you show this work. -3 times +4 is -12. -12 times -2 is +24 plus 1. And now you can use your calculator, or you can add them up in your head. This is -28. Plus 24 is -4, plus 1 is -3. We don't know if that's going to be a max or min yet, but there's only 3 values we're looking at, so 1 is going to be a max, 1 is going to be a min. Might be that one. What's f at -1? That's 2 at -1 cubed, minus 3 at -1 squared, minus 12 at -1. Try to squeeze in the plus 1 there. -1 cubed is -1, times 2 is -2. -1 squared is positive 1 times 3 is -3. Minus 12 times -1 is plus 12 plus 1. So we get -5 plus 12 is 7 plus 1 is 8. And now f at 0, that's going to be an easy one to evaluate. It's just 0 cubed times 2 minus 3 times 0 squared minus 12 times 0 plus 1, which of course all this is 0 minus 0 minus 0 plus 1, and we get 1. And there we have it. We've got, this is our max. You just look at the numbers and see which one's the biggest, 8. Which one's the smallest, -3. And now we'll make a concluding statement. Therefore, the max is 8. And I can write where it occurs at x equals -1. And the minimum, just, you can write it a different way too to show you both ways. You can write it, the max is 8 at this x value, and the minimum occurs at x equals -2 with a value of -3. If you've looked at the textbook question, it actually asks you to sketch to kind of show what you're talking about. Since you've already taken advanced functions, you should know what a cubic with a leading coefficient of 2, that is a positive leading coefficient, looks like. And that is, it's going to be starting down in quadrant 3 and ending up in quadrant 1. So what we have here at -2, we'll have a y value of -3, maybe somewhere down here. But we know it's going to go through like this, and some point crosses the x-axis, but then we know it has to have a local max at -1, 8. So let's assume the y-axis has a different scale. We're just sort of sketching here and showing, okay, at -1, come all the way up to here, but then you have a max value. And now you come down to, at f at 0, it doesn't hit the origin. At f at 0, you're at 1, so that's maybe like right here. It's a different scale than the x-axis. And then it's going to come around at some point. We don't really care what point. We're just looking between -2 and 0 and finding the max and mins. And we've done that. We did it by first taking the derivative, rejecting any values that were outside our range, and then evaluating the values that were within the range and the endpoints to see where's the max and where's the min and what is it. And we concluded with a therefore statement, and we sketched just to show our understanding.